Hello guys, good morning. Now we will continue our series related from TCP header. Here we have covered more point in previous section: source port, destination port, sequence number, acknowledgement number, data offset and reject bits. This is used for future use, and so in segment section this will use as a 0 and used for set of control bits. Now data offset is used for to define, to represent the length of the header. Now acknowledgement, it is a next expected byte number. Now this is a initial sequence number, initial unique number. Now here source port and destination port, there are many categorization we have covered. Now here in this video we will cover flags. This is the flags, this is the 8 bits. Clear? Now in 8 bits, here we will tell you about this point. Here we have write this. Now look at this figure. What do you understand about this? This is the just as a symbol of any brief word. So first, what is CWR? This is 8-bit field, and 8-bit field, that is flags, is known as control bits. So don't worry about this name. Now CWR, what is the meaning of this? That means this is a congestion window reduce. This is a congestion window reduce. Window reduce. Now first we will tell you about congestion window reduce. Here this flag, that means if CWR flag is, if CWR flag 1, if CWR flag 1, then what will happen? That means it indicates that sender has reduced its congestion window size. That means congestion window reduced. That means sender side, due to congestion window size is reduced because there is congestion. So sender reduce the size, and there is the information. How can I recognize? Because CWR flag is 1, set to 1. It indicates the information about this. Now the congestion window size determines the number of packets, because there is a sender and a receiver. Suppose here the sender, and again here we will write receiver. This is a sender and this is a receiver. Suppose this segment is here. Now if this segment, this data goes to receiver side, and during this transmission, this communication, what happened? Because it should after this segment go at network layer where IP addresses work. Now at IP addresses there is many router. Clear? Now maybe here there are more traffics, So there will be congestion, more traffic. Suppose that here more traffic, and more traffic, due to more traffic, that means heavy traffic. Here we are saying heavy traffic. Heavy traffic, that means due to heavy traffic, it will take time to reach out at receiver. So due to congestion, that means here that means we can say that buffering. Here if capacity of this window, this network maybe is not aware, is not have a more capacity. Maybe this has a 1000 bytes, and this has a, this window size has a 1000 bytes, and this has a only 500 bytes. So we will divide it first, because it cannot receive. So we reduced here. Here we will not send 1000 bytes. If we send 1000, it will reject. It will never reach out. So in the same, every here also is buffering. If it is not able to accept the all bytes, so it will send own information to sender. Here according to this window size, it will send the data. So here window is reduced, window size is reduced due to congestion. Clear? Now come at the next point, which is ECE. What do you understand? Now something more detail we will tell you here. Again we will repeat, because somebody is saying about there is more confusion about this, and you can contact with me at my WhatsApp number, which is a because there are many students where we can communicate with. My number is 9457381729. Now when the network become congested, router may start dropping packets. Here we are also again we are repeating this statement. It indicates that network is not able to handle the current level of traffic. Now in response to these dropped packet, the sender reduced its congestion window size to decrease the amount of traffic it sends into the network. It is set by sender to notify the receiver that it has reduced. It has reduced. How can he recognize? Because due to this flag 1, if CWR flag set to 1, that window size is reduced. If CWR flag is set to 0, that means window size is not reduced. That is the point here. That means window size is reduced. Now if CWR equal to 0, that means window size is not reduced. Clear? This is the whole point. So it is set by sender to notify the numbers. So, that means it is set. It is set by sender. This is the whole understanding about CWR. Now come at the next point, which is ECE. Now ECE. What do you understand about ECE? ECE, that means explicit congestion notification. Clear? Congestion notification. And this E is known as echo. Clear? But by default generally we say explicit congestion notification. We do not use echo, but it is the full form of ECE. Now what this is? This is just a type of notification, indication. Which type of indication? Due to congestion. That means, suppose there is the router here. Suppose this is the sender and this is the receiver, and now here there may be many routers, so we can say that there is a router 1, there is a router 2. Now here this is a sender, this is a receiver, this is a R1, this is a R2. Now here sender send the segment. Maybe there are many segment. Here has a sequence number. Now it goes at a router, it select the path at a network layer, and it passes out and reached out at a receiver. Now suppose there is a congestion. If here there is a congestion due to heavy traffic, due to congestion, that means there is the condition to drop out the packet. There is the condition to drop out the packet. That means some packet will be dropped, so it will send notification at a network layer, and we will later on we will discuss about in upcoming video about IP addressing and IP layer, network layer. Then the packet will send a notification. That means because there is a congestion experiences, so it may set the ECN code point in the IP header to indicate the congestion has been detected. Here congestion has been detected. If congestion has been detected, what happens? That means when a receiver receives a packet with ECN code point, if ECN code point set, it may choose the to respond by setting the EC flag 1. EC flag. That means if it received any packet, suppose that, then due to congestion it received, then ECE, there will be EC 1. That means this packet which here in this time is received, if it has EC flag 1, that means due to congestion it will send out notification to sender to adjust this, because because there will be reliable communication. What will happen? Every data will go, but sometimes it will take time, but go every data will be go. Clear? So maybe some packet will be delayed, so due to congestion, so the sender set the packet EC equal to 1. Now in the same manner, receiver can use the same flag set to 1, can use, because it will also send the traffic. Not only sender will send to receiver, receiver will send also the sender. So it is used to both. Now again we can say that means it may choose to respond by setting EC flag 1 in TCP header of the next packet. Here packet will be dropped out, but at network layer this information will pass out, and then at TCP transport layer, this sender set EC flag 1. That means to the sender, this flag is used by the sender to indicate that it has received an ECN from the receiver, that the receiver is capable of handling ECN. Now, if sender is in slow start mode first time, that means it is the rule, it is the behavior of TCP header, TCP segment. Uh, Here packet will data will be segment will be reached out first slow to high motion. First it will slowly will go, then it will be rapidly. Now, if sender is a slow start mode, it can switch to congestion avoidance mode, because if we go slowly, what will happen? We can reach out easily without congestion. If everyone is coming, everyone is going, what will happen? There will be heavy traffic, and heavy traffic there that will take time, so it will be delay the packet. If there is latency, so what will happen? Packet, the condition to packet will drop out. It may fail, because if a receiver will not receive the packet, what will happen? That suppose I am a sender and you are the receiver, and you do not between communication and between sharing this information about this TCP header, and you do not receive about this point. And if sometimes you look at my screen, and there will be pause. Why sir is pausing this time? Why sir is not speaking? Why sir is not sharing the data? You can think about this. But if we move a cursor, then you will identify that there will be problem in, maybe the problem of this screen board, maybe problem of network. You can identify in the same manner. Here will happen for sender and receiver. Clear? So it is used to adjust its sending behavior to better respond to network congestion. It supports both sender and receiver. It is for both sender and you can also, why my student is not responding me? Why there will be problem? Some like issues they here, same issues will happen for you. So it is used to reduce the dropped packet, which can lead to improved network performance and reduced congestion. Clear, guys? Now come at the next point, which is very important. Now we have covered EC. Now we will cover urgent point. Now here we will write urgent. Now what is the urgent? Urgent, this is the full form of urgent. That means if urge, here urge set to 1, urgent flag set to 1. What the meaning of urgent? If flag set to 1, that means this indicate that this data in segment is very significant. That means data is very significant. Now if as 0, that means data is not. That means, what do you understand about this? There will be many packet, there will be many data. Some data will be very important, some data will be as a normalized portion, normal portion. Then if urgent flag is set to 1, that means data is very significant and requires immediate action. Here due to this we can say that requires immediate action, clear, from the receiver. Now we will move on next point, which is ACK, acknowledgement flag. What do you understand about ACK, acknowledgement? Here this is a flag, this is a flag, and before this there was acknowledgement number. Now if ACK set to 1, what will happen? That means acknowledgement field of 32-bit, that means acknowledgement number field will have valid value. That means clear. Now if ACK set to 0, that means will not have. Now that means receivers respond with a SYN and ACK packet to establish connection. Here when we say there is a receiver, there is a sender, here there is a receiver, and if they want to create a connection, here first this send segment, then after receiving it provide the information we have received with the help of some flag, which is a SYN flag and ACK flag. Now this will send only SYN flag. Here SYN flag 1, here SYN flag 1 and ACK 1. Now this is the symbol of a request. This is the symbol of a reply. Now this is the three-way handshake rule as well. If here connection is established after completing the acknowledgement here in last section, because three-way handshake there first connection, second and third will be senders will send a acknowledgement here. Now why we use that means if any packet comes, that means here this is a sender, this is a receiver, what will happen? That means sender send a traffic, then if first time, then only SYN packet will come up, will reach out. Now if anybody receives SYN and ACK packet, that means if they it is also received from you, that means you have received my packet, I have information about you, then you are sending SYN and ACK packet, otherwise you will not send. But without this SYN and you if you receive this packet, that means there will be vulnerability. If there is vulnerability, so we can protect with the help of three-way handshake rule. We provide security to reliability of data with the help of this, to keep track of which packets have been received. But with the help of this we can track the. Now here we are telling about whole TCP three-way handshake. Then we should use here ACK as 1, but SYN here 0. Clear? Now this is a three-way handshake rule. This is a three-way handshake rule. Here again we repeat, if sender does not receive ACK packet, that means it assumes that the packet was lost and retransmitted. Because why receiver, why sender does not receive ACK, that means SYN here, just here SYN packet does not reach out, will maybe it will be dropped out here, packet will be dropped. So it then this type of condition, sender will receive only SYN packet, because SYN and ACK packet will be come and will have SYN and ACK packet. After receiving SYN packet, then it will generated here. Clear? So this is the condition to check reliability and to keep track of which packet have been received. Clear? Now we will move on next point, which is very important. Now that is push function. Here we will tell you about push function. Here, what is a push function? Name gives full information. If push function is set to 1, what will happen? It indicates that data in TCP segment should be immediately delivered to the receiving application without being buffered. That means immediately delivered. In TCP segment without buffering, so no delay. That means no delay about this point. We can say in another way, no delay. Update as soon as possible without waiting complete message or certain amount of data to be accumulated. That means this flag set to 1 can be set to ensure that data is immediately pushed to receiving application. It can increase network traffic and cause network congestion. It is used for large amount of data. Where we use for large amount of data, we will use. Generally this function set to 0, because normally because TCP work as a slowly, so generally this function set this flag set to 0. Now come at the next point, which is the REST function. What do you understand about this? This is the very simple. If set REST function set to REST flag, REST flag set to 1, what will happen? It indicates that connection should be immediately terminated. This is a reset function. That means it is the full form of reset here. First we should understand about REST. That means it is not rest, it is a reset. Reset, why we can say that means we have terminated the connection, so we want again to establish connection. Now we are free, so reset function set flag to set to 1. That means immediately terminated and all data sent or received on the connection should be discarded. Discarded, terminated, this type of term will be used. Now it is used in situation where there is an error or problem, because if you want to send, this is a sender and this is a receiver and this sent to a packet and maybe there error in connection, then we will again reset the connection. So we if there is any problem, congestion and any things will have any error happen, then we will reset the connection. So it is used as a security mechanism because there is a problem in network to prevent unauthorized access to a network. Example, if a host detects a suspicious and malicious connection attempt, it may send a packet with RST flag. Then we should use this flag when it is absolutely necessary, such in case of error or security threats. Clear? So we can use RST flag. Now we will tell you SYN flag. Here we will tell you SYN flag. If SYN flag set to 1, what do you understand? We have again covered. We have covered in previous. Now here where we have covered ACK SYN flag as well covered. Now again we will repeat it. It indicates that the TCP connection is initiated. The sender sends a packet and it wants to synchronize the sequence number with the receiver and establish a connection. That means it wants to establish connection. That means it is used to synchronize the sequence number. That means we can say that after this, if SYN flag set to 1, then sequence number is valid. Now there are more points available here. It sends synchronization request to receiver. Here so we will create a diagram for this to create a better understanding. Here this is a sender and this is a receiver. Now here first here this send to a traffic packet which is SYN. Here SYN packet is reach out. Here SYN flag set to 1 with SYN packet. That means with sequence number, packet with sequence number SYN. Now that means it sends a synchronization request. That means it is request to receiver. It initiates to make TCP connection. To initiate TCP connection. Now this is the first point. First. Now second, here second, it will send. It will send. What will happen here? Here. Now if here data here SYN data is sent, then again it will also send, because this is a sender and this is a receiver, and it will also send a SYN packet set to 1, because some packet will go where. Now it will send also the information of ACK, acknowledgement number, because acknowledgement is indication that we have received the packet, we have received your packet. So that means what is the literary word for this? We can say that it is ready to establish connection, ready to establish connection. Now this is a 3-way handshake. Now again what will happen? Here that means if now here ACK flag 1, This is a third. Now that means it acknowledges the receiver's acknowledgement and that the connection has been established. That means connection established, has been established, but here we will write only established. That means this is the three-way handshake rule. Here we use SYN and ACK. Now SYN is used as a security mechanism, first point, to prevent unauthorized access to a network. If receiver's host does not respond for any SYN packet which allocates for the connection and send SYN ACK back to the host sender, then it prevents connection. That means SYN is used to establish a connection in a three-way handshake. Clear? Now we should move on next point. Look at this point here, fin. If fin set to 1, what will happen? This is no more data. That means no more data. No more data. Now it is used to terminate the connection. Now after three-way handshake we exchange the data. Then if we want to terminate the connection, then we use fin function, fin flag. Fin flag set to 1. Both sender and a receiver send fin flag. Then after acknowledgement, it will they will terminate the connection. Now that means it indicates that sender has finished sending data and is ready to close the connection. It is used when, that means here fin 1, and this is also will send a fin 1 and as well as ACK. Now this will send ACK. Now it is used when a client server has finished transmitting data and want to terminate the connection, then it will used. That means once both have sent fin packets and received ACK packets, the connection is considered closed and any remaining data that may be transmitted is discarded. Now after this no data will be allowed. So it should be used when it is necessary because it can result in the loss of data. Clear? Now we have covered every point, each and every point, and now there is nothing is remaining here. We have covered every point here about flags. Now we will cover next point, which is window in next section. So thank you guys for your support and for your dedication. Thank you.